everyone, it's Mrs. Hardigan, and I'm excited for us to start today's lesson. We're going to be learning about Newton's first law. So today what we're going to do is this. First, we're going to learn who Newton is, Isaac Newton, and why he's important. We're going to get an overview of Newton's laws. So there's 3 laws and kind of overview cover them. And then we're going to dive deep into Newton's first law of motion. We're going to find out what inertia is. We're going to conduct 3 experiments using Newton's first law and learning about it. And then you're going to post a picture of you doing one of the experiments of your choice. Let's get started. Here's a really funny comic. You're lazy, Garfield. I happen to be conducting a scientific experiment, thank you. Lazy, lazy. I'm testing the first law of physics. Lazy, lazy, lazy. Bodies at rest tend to stay at rest. Garfield, you're so funny. So the concepts we're going to learn today. Who is Isaac Newton? What are Newton's laws of motion? How does Newton's first law of motion work? And what is inertia? So in this BrainPop video, you're going to learn who Isaac Newton was and why he is important. You're going to have an overview of the 3 laws of motion. So diving deep into Newton's first law of motion, the first law of motion says that an object at rest will stay at rest, and an object in motion tends to stay in motion with the same direction and speed. So motion, or lack of motion, motion is another word for moving, cannot change without some kind of unbalanced force acting on it. So if nothing is happening to you, like if I'm just sitting here, and nothing does happen to you, you will never go anywhere. So I could sit here and never go anywhere unless something acted upon me. Like it could be even something like someone pushing me over, or it could be something like I get hungry and stand up and go to the refrigerator. If you're going in a specific direction, unless something happens to you, you will always go in that same direction forever. And this is kind of hard to understand. So I want you to think of maybe bowling a ball, but the bowling lane goes on and on and on forever. If nothing stops that ball or slows that ball down, according to Newton's first law, that ball will go in that direction forever in a straight line that you bowled it in. Inertia is the resistance of an object to change its motion, including a change in direction. An object will stay still or keep moving at the same speed and in a straight line unless it's acted upon by an unbalanced force. So for instance, if you are playing the game of baseball, the pitcher takes the baseball and throws it towards you. That ball will continue going on and on and on until either you hit it with the bat or the catcher stops the ball by catching it, or even if the ball hits the ground. But something is going to, an unbalanced force, something will change that ball's direction. If you get a hit, you're going to change the ball's direction and send it out into the field. If the catcher catches it, it's going to stop the ball's direction because it has hit the mitt. And if it hits the ground, it's probably going to stop the ball's movement forward because gravity is pulling it down towards the earth, and then it hits the dirt and the dirt slows it down. So here's some matching pairs. What I want you to do is find the picture or word and match the definition that goes with it. And then today's experiments. So we're going to do 3 experiments. What I want you to do is watch the videos first and then try the experiments. The first one is called ball inertia. An object at rest will remain at rest. The second one is called car inertia. An object in motion will remain in motion. And the third one is called flying ball. An object in motion will remain in motion and travel in a straight line. So here's the ball inertia experiment. I used an egg for it to be more exciting, but I want you to use a ball. Trust me, if you try to use an egg, you will break the eggs, and then your parents will be upset that you broke a bunch of eggs. So don't use eggs, use a little ball. Here's another video of me doing the ball experiment, but I slowed it down into slow motion so you can really see what happens. Here's a video of the second experiment, which is with a car and like a little Lego person or a little stuffed animal. And here's the third experiment with the ball and the string, showing that when you let go of the ball, it will continue to travel in a straight line. So the things that you're going to need are listed here. And for instance, if you don't have a golf ball or a ping pong ball, you could use even like a plastic Easter egg or a foam ball. It doesn't have to be that exact kind of ball, but the ball has to be small enough that it's going to fit into the cup that you have. And you'll see when you watch the video why you need a smaller ball to do that. You're going to need a pie pan, which is what I used in the experiment. But if you don't have a pie pan, you could use a paper plate or even a plastic disposable plate. You're going to need a cup of water, a toy car, some kind of toy person or a very small stuffed animal, a piece of cardboard, or if you can't find a piece of cardboard, you could round up something else from your house that you can create sort of like a ramp with, and then a ping pong ball, a piece of string, and some tape. So there's a lot of supplies involved in today's experiments that you need to get, but these are things you should probably be able to find from around your house. And then when you're all done, I want you to take a picture of one of the experiments that you did and post it and tell us what experiment that was. And that's it for today's lesson. I hope you guys really enjoy it. Have a wonderful spring break. Be safe and healthy. And I miss you guys, and I can't wait to see you after spring break.